Definition of a reference angle. Let theta be a non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive acute angle prime, theta prime, formed by the terminal side of theta and the x-axis. Let's look at this first scenario. So we see angle theta, which is the red angle that I have here, and the reference angle for theta is this green angle. So it's made by the terminal side of my red angle, angle theta, the terminal side, and the x-axis. So a rule that we can remember, if theta is between 90 and 180, so if it's in quadrant 2, then theta prime is always going to be 180 minus my angle. That's what gives me the green part of the picture. On the middle example, my red angle here ends in the third quadrant. My reference angle is between the terminal side of my red one and the x-axis again. So that's my theta prime. So our rule is, if theta is in between 180 and 270 degrees, so if it's in quadrant 3, then theta prime is my angle, my original theta, minus 180. And our last example here, my angle ends in quadrant 4. So my reference angle is going to be the angle between my terminal side and the x-axis again. So anytime we're between 270 and 360 in quadrant 4, our rule is going to be theta prime equals 360 minus our angle. A couple of notes you may want to make. The way that I'm saying that is theta prime. Theta is a Greek letter. Prime is what we call that little tick mark. And then might be helpful to make a note down here that we've got quadrant 2, quadrant 3, and quadrant 4 going on. Find the reference angle theta prime for each of the following angles. For some of us, it might be helpful to draw these out so we can see them visually. Others will probably be fine just using those rules that we just went over. So first of all, let's note that 210 degrees is in the third quadrant. So we're going to take our angle, 210, and we're going to subtract off 180. We get a reference angle of 30 degrees. Next we have theta equal to 7 pi over 4. This angle is in quadrant 4, so we're going to need to do 360 degrees minus our angle. The problem is, though, that our angle is in radians, so we need to remember that 360 degrees is the same thing as 2 pi. So we have 2 pi minus 7 pi over 4. We get pi over 4 as our reference angle. This next angle is negative, so we're going to go ahead and graph this one. Negative 240 degrees would look like this as an angle. And then I know the reference angle that I want is between the terminal side and the x-axis, so this green angle right here. So if I take 180 out of 240, I'm left with 60 degrees, which is my reference angle. And then finally we have theta equals 3.6. Some of you may be wondering if this is a radian or a degree, since it doesn't have a pi or a degree symbol. Anytime it doesn't have a degree symbol, it's going to be a radian. So this is a radian, and we kind of need to think about the different radians we have on our unit circle. So I know that pi is 3.14, so this is going to lie in the third quadrant. So we need to do 3.16 minus pi, or minus 3.14, and we get 0.46 as our reference angle. Notice that all of the answers that we got for reference angles lie in the first quadrant. They have many of the same properties as their partner angles do that lie in different quadrants, so sometimes it's nice to do problems with our reference angle and apply the properties that that triangle has to the other angles. Finding reference angles for angles greater than 360 or less than negative 360. We're just going to start by finding an angle that is coterminal with the angle that we're given, which means it will be less than 360 but greater than 0. we'll get that by adding or subtracting 360 as many times as we need to get it into that range. Then we can do what we've been doing to find reference angles. Find the reference angle for each of the following angles. For problem A, theta equals 665 degrees, I'm going to start by finding my coterminal angle by subtracting off 360. And then I notice that 305 degrees is in the fourth quadrant. So I'm going to do 360 minus 305, and I get a reference angle of 55 degrees. For part B, we have our angle in radians, 15 pi over 4. So to find my coterminal angle, I'm going to subtract off 2 pi, which I'm going to write in the form of 8 pi over 4, since I have fractions. So we get 7 pi over 4, which is again in quadrant 4. So I'm going to take 2 pi minus 7 pi over 4 to get my reference angle, which is pi over 4. For part C, we have our angle as negative 11 pi over 3. In order to get my coterminal angle, I need to add 2 pi a couple of times here in order to get to a positive angle that's less than 2 pi. So I'm going to add on 6 pi over 3. The reason I'm doing that is because it's equal to 2 pi, but it's in terms of a fraction that's over 3, so I can easily do my math here. And I get pi over 3, which is in quadrant 1, which means that's my reference angle. In this part of the notes, we are going to use reference angles to evaluate trig functions. Now, if you have your unit circle memorized, these problems are pretty easy because you just know each part of the unit circle, but you will be expected to show this work by hand, so make sure that you understand the process in this video. So the values of a trig function given by theta are the same values as if we use the reference angle that relates back to theta. So for example, if I ask you for sine of some angle that's in quadrant 3, we're just going to reference back to the reference angle for that angle in quadrant 1. We're going to see what the sine value of that is, and then that's going to be our answer with maybe a negative sign out front. We just have to determine if sine is positive or negative in the quadrant that it's in. So here's our steps. First of all, we're going to find our reference angle, and we're going to evaluate our function at that reference angle. And then, depending on the quadrant that theta lies in, we may need to put a negative out in front of our answer. All right, in this example, we are going to use reference angles to find the exact value of sine of 135. First of all, we notice that 135 is not in quadrant 1, so it's not a reference angle. So we need to find the reference angle for 135 degrees. So I'm going to kind of sketch it out here. 135 lies in quadrant 2. So the way I get my reference angle is I take 180 minus 135. So now we're going to use 45 degrees. We're going to figure out what sine of 45 is and use that answer to move into step 2. So sine of 45, if I think about my unit circle, my y value at 45 degrees is square root 2 over 2. Okay, now in step 2, we're going to think about which quadrant 135 degrees was in. It was in quadrant 2, and when we're in quadrant 2, we know that sine is positive. Therefore, we're not going to put a negative out in front of our answer. So my final answer, sine of 135 degrees, is just square root 2 over 2. In this next example, we are going to use reference angles to find tangent of 5 pi over 4. So first of all, I know that 5 pi over 4 is in the third quadrant, so I'm going to need to find my reference angle. There's 5 pi over 4. We find our reference angle by doing 5 pi over 4 minus pi. We get a reference angle of pi over 4. Now we need to find tangent of pi over 4. Remember, tangent is just y divided by x. So we're going to get 1. Step 2, we're going to think about the quadrant that 5 pi over 4 was in, which is quadrant 3, and we're going to decide whether or not tangent should be positive or negative in that quadrant. Again, we're going to have a positive answer because tangent is positive in quadrant 3. In my final example, we are going to find secant of negative pi over 6 using reference angles. So again, we're going to start with finding our reference angle. We first need to find our coterminal angle since negative pi over 6 is not between 0 and 2 pi. So our coterminal angle is 11 pi over 6. Now we're going to graph that angle and look at what quadrant it's in. So we're in quadrant 4 here. Our reference angle we get by doing 2 pi minus 11 pi over 6. And we get our our reference angle of pi over 6. So now I need to find secant of pi over 6. Secant is just 1 divided by our x value, which gets us 2 square root 3 over 3. Now again, we're looking at the quadrant that secant is in, and we see that it's in quadrant 4. Our x value is positive in quadrant 4, so my answer again is going to be positive.